All right, for our next two problems, something unusual will happen as you try to eliminate one of the variables. So on problem number 4, I'm going to try to eliminate the x because I see that I have a positive 3x and then a negative 12x. So if I multiply my top equation by a 4, and I'll write it underneath here. 4 times 3x would give me 12x minus, and then 4 times 2y, that would be 8y, and then equals, and then 4 times negative 1, which would be negative 4. And then I'll just recopy, and I think that's very important. Recopy the second equation underneath. Don't be lazy about just trying to look at what you had before. So recopy it underneath, and we'll add our two equations together. Remember, I was focusing on the x, trying to get that to eliminate with positive 12x and negative 12x. And that happened. But what I didn't expect was for the y's to have the same thing happen. I have negative 8y and positive 8y. Now notice that this is everything on the left side of the equal sign. I have to have a value there. So when you add a positive and a negative, even when it has a variable, your answer is 0 when it's a positive of the same number as the negative is. So we say that they cancel, but they really add to 0. So 0 will be my left side of the equal sign. And then negative 4 plus 5, that will add to give me 1. Now I have no variables at all, and I have this false statement. 0 does not equal 1. And so when that is the case, all the variables eliminate, and you end up with a false statement, then you have no solution. And remember that when we graphed our systems of equations, it turned out that sometimes our lines were parallel. And so if you get parallel lines, those never intersect. And that's exactly what's going on here. The two lines that we had in the original problem are parallel lines. They'll never intersect, and therefore they have no points in common. There is no solution to this system. So just as a vocabulary reminder, that would mean that this is an inconsistent system. And as we go on to our second problem on this video, number 5, I'll concentrate on the y's this time. Since it's 3 and 4, those are smaller numbers. I'll try to get 12 again, only this time I'm going to have to multiply both equations. So I could multiply my top equation by 4, because 4 times negative 3 would give me negative 12. So multiplying everything, 4 times 6x, that would be 24x. 4 times negative 3y, that would be negative 12y. Then my equal sign, 4 times 15, which gives me 60. And then remember, I'm focusing on trying to get a 12 for my y. So, and I need it to be positive 12y. I'll multiply by 3. So 3 times negative 8x, that's negative 24x. 3 times 4y, that's positive 12y. And 3 times negative 20, that's negative 60. So now I add my two equations. Remember, I was trying to get the y's to eliminate. 12y and negative 12y, that eliminates. But my x's also eliminate. I have 24x and negative 24x. So just as we said in the last one, we have to have something on that left-hand side of the equal sign, so that will be 0. But I look over on my right-hand side, and I'm combining 60 and negative 60, and that also adds up to 0. And so this is a true statement. I have 0 equals 0. And when you have that happen, then your answer is infinitely many solutions. And just a quick review of graphing, that would be where you have your first equation, and when you get ready to draw your second equation, it has the exact same slope, the exact same y-intercept, and in fact ends up being the exact same line. And these are dependent lines. They're consistent because they have they do have infinitely many answers, but they're also dependent on each other. So those are the different situations that can happen. On the first video, we saw where your lines would have intersected in just one point, and therefore you got an ordered pair solution. And then these last two, where something unusual happens, you either get no solution or you get infinitely many solutions. So now if you'll turn to the back of your note page, we will take a look at a quick application. And as we look at that application, the first thing that I will want you to do is to read the problem and then define some variables to go with that problem. So it says a store sells small notebooks for $8 and large notebooks for $10. If you buy 6 notebooks and spend $56, how many of each size notebook did you buy? So we'll look at defining the variables for this. We're looking for how many notebooks were bought of each size. So you can use variables that stand for different words, or you could just use X and Y. So I'm just going to use X and Y. It asks me how many of each size. So I see that the two sizes were small and large. So I'll say that my X could represent the number of small notebooks. Remember, it wanted to know how many were purchased. And my Y could equal the number of large notebooks. Those were the two types. And then your next task on solving a word problem of systems would be to come up with two equations. So one thing I notice is that I've got amounts of money. So it's $8 for every small notebook. So $8 spent for however many notebooks are purchased. And then it's $10 for every large notebook that's spent. So I'm going to go ahead and put that together. And the other money amount that is listed in the problem is that $56 was spent. So I'm going to put equals 56. Now I can't just leave these two expressions without some kind of symbol between them. But since I'm spending a total, hopefully you'll grasp onto total being addition. So 8x plus 10y equals 56. So we have used up the $8 and the $10 and the $56 as far as information goes in the problem. What we haven't used is the fact that 6 notebooks were purchased. Now, if you're trying to figure out how many items there are, you don't really need the money involved with that. So since there were 6 notebooks purchased, you just simply need to add up the number of smalls, that would be X, plus the number of larges, that would be Y, and that would equal your total of 6 notebooks. Now, part C says to solve the system of equations algebraically. So you now know 3 methods. I suppose if you wanted to, you could graph them, but I didn't provide you with a grid, and I wouldn't recommend that. You could also do substitution if you like that method. That would not be difficult to do for this problem. Or you could do elimination. And that's been our lesson today. And honestly, I think that is the easiest way to do this one. So I'm going to focus on the x's, and I'm going to try to eliminate the x. So my first equation has an 8x. I need to have a negative 8x. So I'm going to need to multiply my second equation by negative 8. So I'll do that right here, negative 8x. Remember to multiply everything. So minus 8y equals, and even multiply your 6. That would be negative 48. Now, underneath that, I'm going to recopy my top equation. And I spoke to you about that earlier. You need to recopy your second equation so that they're stacked up and your eyes can see the 2 equations right together. All right, so my negative 8x and my positive 8x eliminate. I have 10y and negative 8y, making 2y equals, and then I have negative 48 and 56, and that will add to 8. I can divide both sides by a 2, and that gives me y equals 4. So I'm most of the way through my problem. I've got y, which is my number of large notebooks. I need to find the number of small notebooks. Now, I have 2 equations to choose from, but one of them is significantly easier than the other. I have x plus y equals 6. Since I know that the y is a 4, I can just substitute in my 4 for the y, and then finish out. So x plus 4 equals 6. You can subtract 4 from each side of the equal sign, and x equals 2. All right, now, I don't have this showing on the video screen, but your part D for this is to write a sentence answer for the solution. So that I don't have to erase everything, I'm not going to scroll up, but I will do a sentence. So the question was, how many of each size notebook did you buy? So you could say 2 small notebooks, that would be your X, 2 small notebooks, and 4 large notebooks were bought. And you could use other synonyms there, but that would be fine to say were bought. And there is your sentence answer to the question, how many notebooks of each size did you buy? So this would be the end of your elimination method notes. Good luck on your homework, and be sure to ask questions as you have them.